All right, congratulations getting through all of our part 1 of this new unit. We're now moving on to notes 2. It should say at the top of your paper, scientific notation with positive powers of 10. All right, let's just read what it says at the very top. Scientific notation is a method of expressing very large and very small numbers as a product of a number greater than 1, greater than or equal to 1, and less than 10. And then you're going to add a power of 10 on it, which we've talked about powers as exponents. All right, let's look at the table. Sea creature, blue whale, 250,000 pounds, gray whale, 68,000 pounds, and whale shark, 41,200 pounds. All right, here's how we're going to change this big number into something between 1 and 10. All right, it says in part A, move the decimal point in 250,000 to the left as many places as necessary to find a number that's greater than 1 or greater than or equal to 1 and less than 10. So if we take this number, 250,000, and we drop a decimal point at the very end, because that's where a decimal point would go, if that doesn't look like a decimal point, that's a little bit better. And if we move it back however many times we need to go, a lot of you might think, oh, we'll just move it to the beginning. But if we put the decimal point at the beginning, it would be 0.25. And 0.25 is not between 1 and 10. So where can we drop it to where it would be exactly between 1 and 10? We can't drop it right here. Sorry, that's supposed to be after the 25, because 25 is much bigger than 10. Again, our number has to be exactly between 1 and 10. So the correct answer is we would move it back around these 3 zeros and then around another 0 and around the 5. That would give us a decimal point of 2.5. And 2.5 is definitely between 1 and 10. So we would write 2.5. All right. Part B, divide 250,000 by your answer in part A. Write your answers as a power of 10. All right. I don't know if you guys have a calculator, but I'm going to go ahead and just tell you that 250,000 divided by 2.5 is 100,000. So let's write 100,000. And then for the second question, it says write your answer as a power of 10. We would write 10 to the 5th power, because what you guys will notice is that if I drop my decimal here and moved it 1, 2, 3, 4, 5 times, that would give us exactly the number 1. So 100,000 is the same thing as 10 to the 5th power. Okay, so now we're going to combine our answers to part A and part B to represent 250,000. So 250,000 equals 2.5 times 10 to the 5th power. All right, how many places to the left did we move our decimal point to write 250,000 in scientific notation? And if you're not sure, again, start at the very end and count backwards. How many times did we go around those 3? And then obviously we went 2 more. So 3, 4, 5. So we ended up moving it 5 places. And that's actually why we came up with 10 to the 5th, because we moved it 5 places. Okay, what is the exponent on 10 when you write 250,000 in scientific notation? Okay, I think what they mean is if 10 is our base. So right up here, if 10 is our base, what was the exponent that went with 10? And that was the 5. And so what we want you guys to see basically from these 2 bullet points is that if you guys move the decimal 5 times, then that would be a scientific notation to the power of 5. Okay, let's check out the gray whale. So the gray whale was 68,000. And if we drop our decimal at the end and move it back all the way to where our new decimal would be some number between 1 and 10, we would move it 3 places and then 1 more. That would put it at 6.8. And 6.8, sorry, that's definitely my dog. Hold on. Okay, sorry about that. We moved it 4 times, so our new number was 6.8. And since we moved it 1, 2, 3, and then one more, so 4 times, it would be times 10 to the 4th. All right, how many places to the left did we move it? 4. What's the exponent with our base 10? 4. So that is why our answer was 6.8 times 10 to the 4th. Okay, let's look at now for the whale shark. 41,200. You would drop your decimal at the end and move it back to where our final first number would be somewhere between 1 and 10. So move it back all the way to where it lands at 4.12. So we would need 4.12. Another thing you guys might notice is I'm not attaching all the extra zeros because 4.12 is the same thing as 4.1200. The extra zeros don't need to be written. They can, it won't be wrong, but in scientific notation, which is what we're doing right now, you leave off the excess zeros. So now we need to look at how many times we move the decimal. 1, 2, 3, 4. So it would be times 10 to the 4th. How many places did we move it? 4. What is the exponent? 4. Okay, to translate between standard notation and scientific notation, you can count the number of decimals, the number of places the decimal point moves. So for 84,000, I'm right here if you guys are lost. For 84,000, the decimal point moves 1, 2, 3, 4 times. That doesn't line up right, but 4 times, which makes it 8.4 times 10 to the 4th because we moved it 4 times. For 3.5 times 10 to the 6th power, if I ask you guys to do it backwards, you would know that the little 6 right here, exponent, tells us we're going to take this decimal and we're going to move it to the right 6 places. So it started here. Okay, let me just clarify something on this part. The decimal started here, but we are going to actually move it 6 times. So it's not going to end there. This is actually not what I want your paper to say. I want you guys to change it in just a minute. So if we move it 6 places, it would be 1, 2, 3, 4, 5, 6. So the decimal would actually go to the end, and it would make it 3,500,000. So let's make it 3,500,000. Take that first decimal at the front and change it to a comma. Should be 3,500,000. Okay, now while my dog is barking again, I'm going to give you guys a chance to pause the video and try all 4 of the your turns. Rocky, be quiet. Sorry. So try all 4 of the your turns, push pause, and then come back and see if you got them right. Okay, for the first one, you should have dropped the decimal at the end. And then moved it 1, 2, 3. And that would be 6.4. 6.4 is definitely between 1 and 10. And it would be times 10 to the, how many times did we move it? 1, 2, 3. All right, this on number 2, it's a really big number. So drop your decimal at the end and count how many times back we would have to move it. There's 3, 6, 9, 10, 11. So it's going to end up at 5.7 times 10 to the 11th. All right, now we're going to work backwards. It's telling us times 10 to the 9th, so we're going to grab our decimal right where it's at and move it to the right 9 times. So it's going to go around these 3, and then it's going to go around 3 more that are empty for now, and 3 more that are empty, and we're going to fill in those empty spaces with zeros. So our final answer here would be 7, 0, 3, 4, and then we had 0, 0, 0, 0, 0, 0. And you can go back and add your commas just to make sure that it would be 9 places. Go back and put your finger where the decimal was originally and count and make sure it ends up being 9 spaces. So you have 3, 6, 9. Good. And again, you could drop the decimal at the end, but it's the same thing as just not even having it, so I just don't even have it there. All right, and then the last one, grab the decimal where it's at and move it to the right 5 places, because that's what the exponent 5 means. So we'll go around these two. Whoops, I don't know what that's doing. We'll go around these two, and then 3 more for a grand total of 5. So 2, 3, 6, 0, 0, 0. So let's make sure that was a total of 5. It was here originally between the 2 and 3, and we went around 3, 6, and then we added a 0, 0, 0 for a grand total of 5. I think that's what that said before I marked on it. And then you can go back through and add your commas if you want. So 236,000. Good job.